So, just to remind you, we've been talking about relations this whole unit. And it's some rule that associates one set of information, could be words, could be numbers, with another set of information, which could be words or could be numbers. And all the elements in the first set are called the domain of the relation. And all the elements of the second set are called the range of the relation. And then we talked about a specific type of relation called a function, where no domain value repeats. Okay, so that's, instead of saying this, you can just say, and I'll use value because we're actually going to start using numbers a lot. Okay, like the relations we've talked about, we've used a lot of words in them. We've used some numbers, but now we're really going to focus on relations that involve numbers. So, if they involve numbers, well, you can show a relation, and possibly if it's a function, in different ways. You could show it as a list of ordered pairs, so they would look like coordinates. And if they look like coordinates, that means they can be graphed. So that's another way that you can show a relation. And one of the ways we did graphing was using a table of values. So that's another way to show a relation. Okay. So let's just talk about when we get values in a relation, how we write the domain and range, and how we determine whether it's a function. So we've got two relations here. So for R1, I want to, and I'll just put D for short, list the domain values, list the range values, and then state whether it's a function. Remember, the domain values are all the first numbers in the pairs, if it's ordered pairs. What are all the numbers that you see in the first pairs? 1, 2, 3. And then what we do is we put brackets around to show that it's three numbers, 1 and 2 and 3. What would the range be? Yes. 4, 6, and 8. Is it a function? So you look at the domain values. Do you see a domain value that repeats? No. So it's a function. For relation 2, which is shown as a set of ordered pairs, let's do the same thing. Domain, range, and whether or not it's a function. What's the domain of relation 2? And if you see a number more than once, you don't have to list it more than once. 1 and 3. And it's just those two numbers, which is why we use braces. What would the range be? 4, 6, and 8. And is this one a function? No, because the domain value 1 repeats. So not a function. And if you're asked for an explanation why, just say domain value 1 repeats. So this one is shown as an arrow diagram. Again, I want to do three things: domain, range, and whether it's a function or not. So remember, in an arrow diagram, the domain is all the values in the first oval, the one on the left. So what would the domain of this relation be? And what would the range be? 0, 4, and 8. Is it a function? Why?
Because there's 2 arrows pointing to 8.
That's actually not the reason. It's not a function, but for a different reason. It's okay if the 8 repeats. It's okay if a range repeats. But what's repeating here in this one? -4 is repeating because it has 2 arrows coming out of it. So not a function. Because this repeats, it's got 2 arrows coming. So those should be pretty straightforward. But now let's move on to graphs, which can get a little challenging at first, but you'll get it. You'll get the hang of it. Okay, so let's look at the first graph. It's a series of dots. That's actually pretty straightforward when it's a series of points. What are all the domain values? In other words, what are all the x coordinates? Start from the left to the right. What's the x coordinate of this one? -1. This one? 0, 1, 2. Remember the x coordinates. So we've got -1, 0, 1, 2. Now we got to list the y coordinates. What's the y coordinate of this one? This one. So I don't have to write it twice. This one. And 4. So 1, 2, 3, 4. Is it a function? No, it's not. And why is it not a function? Which one repeats? Which x value repeats? 1. Because there's the point 1, 2 and the point 1, 3. Okay? Okay. The next one. The next 2, actually. These are different because it's not a series, it's not a set of points. It's a whole series of points. Like here, there were 5 points in the relation. How many points are from here to here? Bend your mind a little bit. Infinite, right? There's a point here, and then there, and then there, and then there, and then there, and it just goes on forever. Okay? Same with this one. So when we have lines or curves or shapes, the domain and range is going to be a little different. What is the x coordinate of the point to the furthest left on this line? -3. What is the x coordinate of the point to the furthest right on this line? 4. And because it's connected, doesn't that mean every number from -3 to +4? Do you remember how to write that? We just did it on Friday. Well, it's not infinity. It starts at -3 and it goes all the way to 4, everything in between. Remember how to write that? Using, let's start with interval notation. Okay, I start at -3. Do I include it? Yes. So I put a bracket, -3. It goes all the way to 4, which I also include. So notice the notation changes. We have to use interval or set notation when we get lines or curves or shapes. And you may also be asked to write it using set notation. So you have, I always like to start with interval and then I convert it to set. How do I write everything between 3 and 4? Well, I do -3, +4, put an X in the middle because it's domain, and then put the arrows like so, with equal dashes below. Those mean the same thing. Don't think left to right now. Think lowest to highest and think Ys. What's the lowest point on this graph? It's here. What's the Y coordinate of this point? -2. And then it's everything in between going all the way up to a Y coordinate of +2. So it's everything from -2 to +2. How do I write that? Bracket, -2, +2, bracket. And then if we did this using set notation, start at -2 and at +2, but notice this time, remember range is all the Y values, so I'm going to put Y instead of X. And then I put the arrows for the inequality signs to the left with the equal notation underneath, because I'm including. So here's the next question for this one. Is it a function? Do any domain values repeat more than once? No, because if the domain value repeated more than once, you'd have different points like this, or you'd have little segments coming off it. So no, it doesn't. So therefore, because domain values don't repeat, it is a function. This next one. So remember what I was saying when I started this one. Domain furthest left to furthest right. Range lowest to highest. What is the X coordinate of the point to the furthest left? What do the arrows mean? Keeps going, right? So where am I going to? Not infinity. I'd be going that way if I went to infinity. I'm going to negative infinity. And remember, parenthesis around that. So it'd be negative infinity. What's the X coordinate of the point to the furthest right? Well, the point to the furthest right is there. What's its X coordinate? 0. And I include it. How do I write everything less than or equal to 0 using set notation? X less than or equal to 0. the range. Now you got to think lowest to highest. What's the y coordinate of the lowest point on this graph? Negative infinity. Not only does this go to the left, it also goes down forever. So it goes to negative infinity. What's the highest point? Doesn't this mean it keeps going up forever too? Like not only it's going to the left, but it's also going up forever. Positive infinity. That would be the range. Do you remember how to write this using set notation? It's the funky notation. Remember, we're going to use Y for range instead of R. Remember the two letters. E. Yeah, that's right. Now, is it a function? What's the x coordinate at this point? -1. What's the x coordinate at this point? So -1 repeated, didn't it? There's a whole bunch of them that repeat. There's infinite ones that repeat. So, not a function. There's actually a way you can do it for graphs without having to like look for points and see if things repeat. And that's something called the vertical line test. Vertical line test is this. If you can draw a vertical line through more than one point, on a graph, it is not a function. In other words, it fails the vertical line test. So let's go back to those three up top. And I'll see if we can see how the vertical line test works. So look at the dots, the points. Can you draw a vertical line through more than one point? Yeah, right there. That tells you not a function. Can you draw a vertical line through more than one point on this one? No, you'll only hit one point all the time. That's why it's a function. Can you draw a vertical line through more than one point on this one? Absolutely. You can draw a whole bunch of them. Not a function. So that's a bit of an easier way when you encounter a graph and you're asked to state whether it's a function or not. Okay. So let's look at some examples. First example. All you're asked to do with these two graphs is state whether it's a whether it's a function. First one, think vertical line test. No, because I can draw a vertical line from here. I could draw a vertical line and hit more than one point there. Therefore, not a function. And the explanation would be, I can draw a vertical line through more than one point. How about this one? Can I draw a vertical line through more than one point? Nope, which means that it is a function. Okay? Be careful with that. Don't get that confused. If you can draw a vertical line, it's not. If you can't draw a vertical line through more than one point, it is. All right, we've got a couple of graphs here. We're asked to find the domain and range of each. So we don't have to worry about whether it's a function or not. They're actually, it says for the functions because I can't draw a vertical line. Okay, because they're curves, we're going to have to use that interval notation. So for domain, furthest left to furthest right, look for arrows on the graph, because that means things go on forever in some directions. What's the x-coordinate of the point to the furthest left? Not only does this go up, but it's also going slightly left, isn't it? So, and it's doing that forever. So what's the point to the furthest left? Negative infinity with a parenthesis. But to the right, it stops here. It doesn't go any further. What's the x-coordinate here? 3. And because I'm good, put it back. How would I write that using set notation?
X is less than or equal to 3.
X is less than or equal to 3. X. Now for range, lowest to highest. Change your thinking. And y coordinates now. What's the y coordinate of the lowest point on this graph? Well, first of all, we've got to locate the lowest coordinate. Isn't it here? What's its y coordinate? -1. And I include. What's the highest? Watch your arrows. Infinity, I thought I heard you say, and that is correct. Why? Because this arrow means it goes up forever. And how do I write this using set notation? Well, I'm using y now, and everything bigger or equal to 1. So I got to do this. Yeah.
How does the arrow switch negative infinity to positive?
Because it's lowest to highest. So lowest is -1, but if it's going up forever, that's positive. Right? Yeah. Anybody want to take a shot at this? Left to right, x coordinates. Left to right. 2, TO. What's the highest? Got it. Perfect. So here's the point to the furthest left. Its x coordinate is -2. Here's the point to the furthest right. And it's everything in between because it's connected by a curve. And if it's between two numbers, that's when I do the two inequality symbols. like so. Notice if we've got, when we're converting between interval and set, if you've got a negative infinity and a number, it's always going to be less than or equal to. If you've got a number and positive infinity, it's always going to be greater than or equal to. If you've got two numbers, it's always going to be double with the arrows. Range. Change of thinking. Y coordinates, lowest to highest. Well, I got two low points here. What are the Y coordinates? 0. So that's where I start. And I go all the way up to, but stop here. I don't go any higher than that. And that Y coordinate is 2. And how would I write that using set notation? I've got two numbers. What do I put in the middle? Y. And then two less than or equal to symbols with the arrows pointing left. Okay. Okay, let's oh. That's not right, is it? Oh. Oh, there it is. Okay, good. Okay, similar question. This time we've got an actual situation. So it shows the number of fishing boats anchored in an inlet over time, and it's given in 24-hour time. So at 9 a.m., looks like 25 boats are in the inlet. At 1 p.m., which is 1300, looks like there's 6, and so on. Is this a function? Can you draw a vertical line through more than one point? No, which means it is a function. So, and why is it? What's the explanation? Domain never repeats. Here, we're asked to identify the independent and dependent variables. Remember how to identify them on a graph. Independent is the X, dependent is the Y. So what would the independent variable be? Time. Which means the dependent will be number of boats. And finally, the domain and range. Notice in this graph, there's no connection between the points. So we're not using that interval notation. We're using the braces, because we're just listing a few numbers for each. I'm going to use the fancy braces. So remember, let's see, for X coordinates or X coordinates or X values, I've got 9 a.m. and it looks like 10 a.m., 11 a.m., 12, 1300. Looks like it's going up by an hour every time. So I've got 0900, 1000, 1100, 1200, 1300, 1400, 1500, and 1600. So let's just say this to this. Let's make it a little bit easier for this one instead of listing them all out. So it's every hour from 0900 to 1600. And the range would be all of the y coordinates. So we can go from left to right if we want. What's the y coordinate of this one? 25. This one? 10, 8, 6, and 6. I'm going to have to write the 6 twice. So 10, 8, 6. Back to 10. I've already got it. This one, 11, and this one, 15. Okay, last example. This is stuff we've done before. It's just using the new words we've learned. So remember, this is a way to show a function where we use f of x. If I show it relation-wise, it means the same as this. These two mean the same thing. Y equals negative 3x plus 7, f of x equals negative 3x plus 7. The only difference is this means it's a relation. This means it's also a function. And then when you see range value, that's y. So basically it's saying determine y when x is negative 2. So let's go to the graph. X is negative 2 here, right? So I got to go up to the graph and see what the y coordinate is. What does that y coordinate look like? Be careful here, we're not going up by 1s, we're going up by 2s. So this would be 14. This looks like it's halfway between 12 and 14. So y equals 13. And that's using the graph. But you could also find it using algebra. Use this. When x is negative 2, calculate y. So plug in negative 2 for x. Negative 3 times negative 2 is 6 plus 7. Y equals 13. So we were right on the graph. For the next one, we're asked to find the x when y is 4. So we got to go up to 4 on the y, and then we got to go over to the line to figure out what the x is. What's the x coordinate there? 1. And that looks pretty clear. So from the graph, x equals 1. We could still do it using algebra. This time you're told that the y is 4, and you've got to figure out what the x is. So your equation is going to look like that, and you've got to solve for x. So to do that, I'll leave the x over here, subtract 7 from both sides, and I get negative 3 equals negative 3x. Divide both sides by negative 3, and I get x equals 1. Matches up with what I did on the graph. Okay,